Okay, so this is a real quick video on how to do linear correlation using the TI-84 calculators. And the nice thing is it's not really much different from any of the older models. The one thing to keep in mind here is that for historic reasons, there's actually a lot of different places where you can find linear regression in the TI calculator. So you just want to be careful. Make sure you are not using, if you go under the Stat button and under Calc, you'll see a linreg ax plus b function that's pretty commonly used, but not in this class. There's also a linreg a plus bx. We don't use that in this class either. The thing that we do use is under the Tests submenu. And under the Test submenu, you'll find the function linreg t-test. So linreg t-test is exactly what you want. So the other functions don't always give you the values that you need. So it might not give a correlation coefficient, but it definitely doesn't calculate p-values and that sort of thing. So this is what we want. Now it needs some different inputs. It needs the x list, which is your independent variable, y list, which is the data from your dependent variable. This frequency you can always just set to 1, that's fine. And then for the hypothesis test, we're always doing a hypothesis test that looks like the null hypothesis is that rho equals 0, and the alternative hypothesis is that rho is not equal to 0. So we're always just going to choose the option here for not equal 0. All right, now I haven't entered my data yet, so I'm going to do that first. So I'm just going to hit Stat again, go into the list editor. I've already got some things in there, so I'm just going to highlight the name of the list, press clear and enter, and then just start putting in the data that's provided. All right, I'll do that as quickly as I can for you here. Okay, just about there. Great. So once that data is in, then we can start doing the linear regression process. So just hit Stat, go over to Tests, and you can actually save a little bit of time if you scroll up, because linreg t-test is so far down the list. If you scroll up, it goes to the bottom of the list first. Regardless, linreg t-test is what you want. We've already got our settings taken care of. Oh, I didn't say regression equation. You can just leave it blank. That's fine. Press Enter. It will do all the calculations that you need. All right, so the first thing that we generally need is the correlation coefficient. And so that correlation coefficient is all the way at the bottom. It's R. So the correlation coefficient here is negative 0.833. All right, so generally we'll need that because that tells us if that is close to 1 or negative 1, then that tells us that there is a pretty good linear relationship between the data, and we can use the line of regression for prediction. Now, the line of regression, we get that through a line equation that looks like the form y equals mx plus b. So the calculator provides that. If you'll notice at the very top it says y equals a plus bx. So the b is the slope of the line because it's multiplied by x, and then a is the y-intercept. But also in this output, it's given us the values of a and b. So b here is negative 0.19. So this would be like y equals negative 0.19x. And then b, we just used b. A is 78.12, and that's going to be the y-intercept, so plus 78.12. And that's our line of regression. And we have a pretty good correlation coefficient, but it's not really, really close to 1. So the way we know for certain as to whether or not that is close enough to 1, we use a hypothesis test, which requires the use of a p-value. And that p-value is actually calculated here as well. So I need to scroll back up, and there it is. So 0.039, that's the value. That's the p-value that's provided. 0.039. So fairly small p-value. If this was a hypothesis test where we wanted a 5% level of significance, then the p would be lower than the level of significance. So we would reject the null hypothesis, stating that that is not true, leaving this to be the true statement, so that the correlation coefficient's not equal to 0, meaning that there is a statistically significant correlation between the data sets.